Hey guys, how you doing? This is Arjun Sondhi again, and we're going to continue where we stopped off last time with a question which was, given these parameters, could you or could you not afford to buy 2 units of good 1 and 2 units of good 2? So I'm sure you guys figured out the math here. The reason you cannot buy that combination is because if you buy 2 of good 2, that'll cost you 20 rupees, and if you buy 2 of good 1, that'll cost you 10 rupees. So the 2 of them exceeds your income of 20 rupees. So I also wrote down all the remaining bundles that you can afford to buy given these parameters. All right, so hopefully you are now familiar with the way we write down these concepts and the terminologies in this topic. So today we're going to talk about budget line. So this is a graphical representation of the theoretical stuff that we built out last class. So I'm going to write down the equation again, and then I'm going to manipulate it slightly to get the purpose that we want to get to. So here's your budget constraint: price of good 1 times the quantity of good 1 plus the price of good 2 times the quantity of good 2 gives you the income that you have to spend on those. All right, so we are going to take this equation and represent it graphically. So we always put good 1 on the x-axis and good 2 on the vertical axis. Obviously, you know this is the origin, which is 0, 0. And as you move to the right of this, you will be increasing quantity of good 1. And as you go up on the vertical direction, you're going to increase the quantity of good 2. So we are going to graphically represent this equation in this space. So let's look at the intercept. If you want to consume, given these parameters, if you want to consume nothing but good 1, which means you're not consuming any of good 2, the total amount of good 1 that you can consume is going to be m divided by p1. And that is known as the horizontal intercept. And we're going to do the same thing for the vertical axis. If you choose to consume nothing but good 2, which means you do not want to consume any of good 1, then all you have to do is spend all your income on good 2, which costs p2. So your vertical intercept is going to be your income divided by p2. So those are usually a good starting point when you're graphing this, because it gives you your endpoints. And now we can look at all those combinations that we talked about, and you can probably guess here, if I want to consume more of good 1, I have to give up some of good 2. So if you make this representation graphical, you're going to have a downward sloping line which represents your budget constraint that we talked about last time. So this is just a graphical representation of that equation. And now we are going to change it just so we can analyze this model a little bit more. So you've probably learned in your math class that in your equation of a line, any generic line, is y equals mx plus b. Right, so that's just a very generic equation of a line. If you're not comfortable with this, I would highly encourage you to go look through our videos and find the math video on equation of a line. So getting back to our model, if we solve, we know x2 is the y-axis. So we have to solve this equation for x2 because that's what the vertical axis here is. So we're going to just take this equation and alter it to solve for x2. So all I'm doing is taking x2 to one side. x2 becomes m minus p1 x1, and then you have to divide through by p2, so all you're left with is x2. So this equation mathematically is identical to that equation, where you have the vertical axis is some function of your variable on the x-axis and a constant. And again, if you're comfortable with your math concepts, this variable here, m, represents what? It represents the slope of the line that you're drawing. So in our case, the intercept in front of x is negative p1 over p2. And that for us is going to be the slope of this budget line. So the slope of this line is negative p1 over p2. So you see there's a negative in front of it, which makes sense because that tells us that there is a negative relationship between how much of good 1 and good 2 we want to consume. So in economics, a lot of times we just ignore this sign because we know that there's a negative relationship, and we just look at the absolute value of p1 over p2 to represent the slope. Again, if you're not comfortable, you can keep including the negative sign there. It does not make a difference in analyzing it economically. So one more thing before we conclude today's video is what does the space here represent. So each point on this line, a point inside the line and a point outside the line, and the relationship between x1 and x2 is what we have left for today. All right, so every point that you are on the line, so for example point A here, point B here, means that you are consuming some combination of good 1 and good 2 and using all of your income. If you are if you are consuming this bundle here, then what that means is that you can afford to buy that bundle, but you're not spending all your income. And we'll do a numerical example to start next class. And if you are wanting to consume that bundle there, that is outside your budget constraint. So you cannot afford to buy that. That's like the example that we started this video with of 2 of x1 and 2 of x2. All right, so we have one more thing left before we conclude today's video, and that is to look at the relationship between if I want to consume more of x1, how do I determine how much of good 2 I have to give up? So it's easy to look at it numerically. Let's just look at that example. So if I want to consume more of good 1, how much is it going to cost me? That's right, it's going to cost me 5 more rupees. So that's the price that I pay for good 1. Now you have to ask yourself, how much of good 2 can I buy with the amount of money I want to spend on good 1? So with 5 rupees, you obviously cannot buy a whole unit of good 2. In this case, you can only buy a half, which if you look at the equation we have there, negative P1 over P2 is negative a half, which is the relative prices of good 1 to good 2. But I want to make sure that you understand, just not mathematically, but why that's the case. Right? So let me just review it one more time. If I want to consume one more good 1, it's going to cost me 5 rupees. Then I have to ask myself, how much of good 2 will I be giving up if I want to consume one more of good 1? And in this case, I can only afford to buy a half a unit of good 2 with 5 rupees. So this number, negative a half, or this variable negative P1 over P2, which is the slope of your budget constraint, has a very important interpretation. It tells you the relationship between how much of good 2 I must give up to get one more unit of good 1. So make sure you can put all of these different ways to represent the same material in an equation, in a graph, and mathematically how x1 and x2 and the relationship between the consumption of x1 and x2 are related when you are given a fixed income and some prices. And next time we'll talk about when you change these variables, right? Obviously, if your income goes up every week, then you will be able to choose outside these constraints, or when these prices change, we might be able to change our behavior as well. All right, so that's what we'll get into next time. Have a good day and see you next time.